Hey friends, software is everywhere, putting us devs on the front lines of innovation, improving people's lives, shipping new and better features, all while moving faster than ever before, which is where our friends at Raygun can help. Their powerful error and performance monitoring tools make it easy to get all the diagnostics you care about for your team's web and mobile apps. When there's an issue, it shows you exactly what's going on, who's being impacted, and how to fix the root cause, down to the specific line of code. See how your users are experiencing your website or app in real time and ship better code faster with confidence, knowing that Raygun will alert you to any new issues or regressions. Start a free 14-day trial of Raygun today and try it for yourself. It only takes a few lines of code, and their simple usage-based plans start at $4 a month, a small price to pay to get your team and users to love you. Visit raygun.com. Try it out. Thank me later. Hi, I'm Scott Hanselman, and it's another episode of Hansel Minutes. Today I'm chatting with Bilgem Çakır. He is the CTO of the Clay Token Game Studio and has also worked at Amazon and Microsoft. But you've been a game developer and a demo developer for as long as you could code. What is a demo and what is the demo scene?
Demos are, when in the software industry we hear that word, we think many things. But in the context of demo scene, demo means a very specific thing. It's an executable program that is usually non-interactive. You sit back and watch this thing. And they look like music videos in a sense that there's usually some music that is synchronized with some digital art and visual effects, with usually the point being that these are kind of difficult to code, competitive type of programming involved with these effects. So it's a little executable thing that may run somewhere between 2 to 10, 15 minutes that will try to impress you as much as possible. And like I said, the one of the main things is about the competitive aspect of it. So Demoscene is the group of people that make demos with an eye towards competing with each other, as well as making art. And we talk about things like world records and world firsts on certain effects. And that I can't emphasize enough that competitive aspect of it, I guess. But that's what a demo is.
Okay, and I as a consumer, I was never a creator of demoers, but as someone who was on a home computer in the early 1980s, I may or may not have procured software in a non-legal way. And as I would load up that software in the opening, I would see like the welcome, the splash screen, what we would think of as a splash screen. I mean, right now you see Unreal Engine or Crysis or CryEngine, and you see little moments. If you watch a movie, you see the opener of the Marvel, intro, and you go, wow, that's exciting. And it gets you excited. And the people that would crack these games or these things that I would, somehow procure had these impressive screens, and I would start to know their names.
Right.
But it wasn't necessarily that people who made demoers were also pirates of software, right? The demo scene is much bigger than that. But this was an opportunity to advertise, isn't it?
Correct. I mean, there is an existential tie between the two. The crackers were first. Crackers were there before demo scene really materialized. And the first demo-like things were exactly what you called out, what we called intros, technically. Those opening things before the game. And there, the crackers would boast about having been able to crack the copy protection of such and such game and now making it available, etc. But as time passed, people started to make more and more visually striking, impressive intros, to the point that people started competing on how impressive the intro is, as opposed to previously competing on cracking the games. At which point, the demo scene started to branch out of the crack scene and became its own thing, where people no longer were interested in cracking a game, but making just standalone, impressive visual, audiovisual effects and stuff. So that you're right. They are, and some people continue to do both. But as of early 90s and onward, I can kind of safely say that Demoscene has been its own entity that's completely legal and mostly focused on making demos.
Yeah. And as a consumer of these things, it became interesting when the game that you wanted to play was a letdown because the intro was so much more impressive, which would then lead me to stop downloading games and start downloading demos because you would see effects and you would see experiences that were far beyond whatever silly thing like Pitfall or Impossible Mission that you were trying to download. Which then makes me wonder, why were the demos so much more impressive than the games if the demo people are also writing games?
I think that observation varies between platforms. I should start by saying that. So, for instance, my most familiar platform, the one that I've worked most on as a demoscener, has been Commodore 64. On Commodore 64 Demoscene, the Demoscene really started early on and it matured. And by the time it really got to creating some of its most impressive work, late 80s, early 90s, the Commodore 64 as a commercial platform was kind of on the decline. And the games that were being produced were kind of going down in budgets and stuff like that. So the most kind of signature games of Commodore 64 comes from an era from, say, 84 to 87, maybe, whereas the Demoscene went beyond that and became its own thing in the 90s.
Interesting. Okay, so let me ask an analogy. You know, when you get an Xbox or a PlayStation, we talk about the first generation games, but the developers are still learning what it can do.
Exactly. Yes.
So you're saying that by the time the developers are like, now we've got the Commodore 64 by the ears, and we can really, it's too late. Now we're on to the next thing.
Right. For the gamers, for the game developers, for a commercial activity like game development, they by then move on to like making games for Amiga and the 16-bit machines, etc. Whereas the demosceners that stay on the Commodore 64 are, teenage kids that have their Commodore 64 and hasn't necessarily gotten an Amiga yet, and therefore they keep, competing on that. And therefore by 94, 95, you can have some amazing demo techniques. And in fact, some games that, people who are in the demo scene end up making that are technically super impressive, but the platform is no longer a viable commercial platform. So there, the demo scene is ahead of the games. But we can't necessarily say the same thing for the modern PC scene, for instance. I believe in it, like having seen the PC game industry as well as the PC demo scene. I think most of us would agree that a typical AAA game does stuff that we don't see in a demo, right? They are ahead of the demos. Like demos may achieve things like you called out with, like the 4K and like size limited things. That there are still some impossible seeming stuff that happens in demos, but as a general level of polish and technical achievement, the games on PC or consoles are not be that much behind, demos.
Right.
So that's like I said, it changes from platform to platform.
Right. And you bring up an interesting juxtaposition. So the example that I gave where the demos felt more impressive than the games, that was 40 years ago. So here we are 40 years later. Why is the 6502, 6510 computer still having demos come out? There were some amazing C64 demos that came out this year.
Correct.
In 40 plus years after the Commodore came out.
Yeah, demo scene has. There are, people have different motivations to be involved with demo scene. Some people really treat it as an outlet for, digital art creation. Other people find it interesting and emotionally, connected to them because of the nostalgia factor. And then yet others are interested in it because it's a well-defined platform. I kind of fall into this camp. I'm not a Commodore 64 demo scener because I find it nostalgic. I am interested in it because it is a well-defined platform that's not changing. There's not a new graphics card every year. It's the same exact platform. There's a bunch of us that are competing on it. So it's a platform where I can solve some interesting technical problems on and compete with it. And there happens to be some really great people to compete with in the C64 demo scene. So I go on, and a lot of people are like that too. So I think that type of motivation somewhat answers this time access question the best. For us, it's not, I mean, what if it's 80 years? I mean, as long as it's the same, it's like, the rules of soccer or any competitive sport don't necessarily change that much from decade to decade to decade, but people are still interested. It's that same set of rules, and we try to achieve even more and more and more with the same set of rules.
That is such a lovely answer, and it even like shocked me a little bit, because there's a sense of the new and the more, and I want gigabytes and I want terabytes and I want petabytes. But yeah, you're right. Like, yeah, there have been improvements in quality of baseball and soccer and even chess.
Right.
But no one's complaining. Why are we still playing chess in 2022?
Yeah,
you're absolutely right. I think people look at the demographic. I'm playing with my Commodore 64, and I'm talking about it on TikTok, and people are like, "Come on, boomer, what are you doing? Combining the new TikTok and the old Commodore 64." But then I'm starting to find my people and realizing that it's okay for me to be excited about this computer even now.
Yeah, and I mean, even for people who come to it from a nostalgic point of view, that's totally fine too. Like, I'm not against that. There are people who are interested in their, Volkswagen cars. There are people who work on their like 1956 Chevys and stuff like that. So there's that aspect too. That's totally fine. It's just that I usually liken the motivation of a demoscener to that of a circus performer. So if you think about a circus, like kind of even think about the modern circus, like the Cirque du Soleil type of, there's art in it too. It's not just like, look, I can do 10 balls at a time, 11 balls. Like there's a competition aspect for sure, but there's also the presentation with synchronization with the music. There are moments in the presentation of a particular act in Cirque du Soleil that the music will crescendo to this thing, and they'll do this really difficult thing, and then like there'll be a pause for the music to kind of trigger people to clap, and there's an interesting showbiz slash challenge slash art combination of things going on. And I think that's very same thing happens in demos. A well executed, well built demo to a kind of knowledgeable audience creates the same response. Like you watch this demo and you go, oh my God, they're doing, oh, this is already incredible. And then like they'll add one more thing. And it's the kind of the Steve Jobs one more thing happens at every screen in a demo typically, right? So that's exciting. And at that point, when you look at the problem at hand this way, again, similar to the sports example, I may be a painter using oil paint, and people have been doing oil paintings for centuries, but that's no reason to stop making oil painting right now. Like we can still use existing tools to create new things. That's the important part. Like that we are not only doing the same demos, same effects people did in the 80s. We are doing stuff today on a Commodore 64 that nobody were able to do for the previous 40 years, right? I mean, that's the one of the biggest motivations to me. When I break a world record on Commodore 64 on 2022, I get the satisfaction of knowing I've just achieved something that some of the best coders in the world could not have been able to do for 30 years. I just beat all of them. That's an insane satisfaction. that's really satisfying and inspiring. Likewise, if I see someone else have a world record today, even beat my world record today, I get the same excitement because now that I've witnessed someone achieve this. It's like watching, Usain Bolt break a world record in Olympics. It excites us all as the entire humanity. So we got kind of a same kick from Demoscene, I guess.
That's great. I love that. And the idea of the impossible, like you said, that someone did something today in 2022 that they couldn't do, that no one, what is it that prevented it? Was it knowledge? Was it the knowledge of the previous 40 years? Was it no one ever thought of it? Did you find a corner of the Commodore 64 no one explored? What prevented it from being possible, and what made it possible?
Yeah, I would say there are, in terms of the technical breakthroughs, there are, I'd like to think of them in two categories. One of them is kind of what we call the VIC effects. The graphic chip in Commodore 64 is called VIC, and we have a whole bunch of effects that are about kind of finding these things, like I mean, one of the earliest examples being, opening the borders. Commodore 64 has borders. You shouldn't be able to show anything there, and then somebody figures out a way to show things in the border, and now you have a breakthrough. And a typical bitmap for a 4x8 pixel multicolor picture, for a 4x8 pixel area of a picture, you are supposed to have only 4 colors. Somebody finds a way to cram in 16 colors in there. These are the types of effects that shouldn't be possible, isn't advertised in the hardware level, and somebody just goes through and tries to reverse engineer the internal gate structure of the chip and figures out that, oh, hey, actually this one register that tracks the raster line and this other register that we use to set up, vertical scrolling, when their, last 3 bits are the same, Commodore does this like bad line thing and is able to read new colors. So what if I do this, like change this value of the register every line? I get cram in the 16 colors, which is called the FLI graphics. So that kind of a thing is this weird research / reverse engineering journey. And a whole bunch of coders in the demo scene are into this type of effects, and they try and notice things, notice different behaviors when they keep playing with the registers and find those things out. Some of these things are basically side effects of the way the original chips were designed, that nobody really aimed for them. Same thing is true for like illegal opcodes. People keep trying different hex values for opcodes, and some of them just crash the computer, but every once in a while a few of them tend to do some useful things in less cycles than it would take to do the thing by legal means. So that there's that. And to be honest, that's not my forte. Like, I'm not one of the coders that go after this type of hardware figuring out reverse engineering type of effects. I go more for the math type of effects, like vectors and 3D dots and 3D tunnels with free camera angles, etc., etc. In those types of effects, there's no magic. Like, we don't look around the computer and try to reverse engineer and find out that there's this one register, when you set it to this certain value in this certain cycle in the line, like weird things happen. The math codes, typically, it's very similar to any other platform. It's just really trying to understand the math functionality to a very good level, while balancing the memory layout to be very hardware friendly, and like combining optimizations of like lookups versus unrolling loops versus taking a loop into the 0 page, where operations are 1 cycle cheaper. So it's just this kind of, what 7 things should I do to save off 2 more cycles out of this 1,000 cycle operation? If I can do that, then I can, break the record of the previous person. So that space is more open, I feel, but also it's more vague when you break a record or do achieve something for the first time. You don't really know whether you achieved it because not enough people really worked on it, and like what you achieved isn't that hard, but it's just, you just happen to be the first person that goes there. If that's true, then like somebody else will come quickly beat your thing. But if you achieve something, if you achieve an effect, and then for years, for decades, nobody else is able to beat it, then you understand that, okay, like this person really pushed the envelope here. to pretty much a difficult place where no one else has been able to beat them. But to answer your question, yeah, like these two different categories have different meanings of pushing the envelope. But also, it's important to keep in mind, especially for older platforms like Commodore 64, Spectrum, Amstrad CPC, these kind of older 30-year, 40-year platforms, even in like Amiga, the 16-bit generation, the Amiga 500s, any new any new thing we see on these platforms is generally going to be really quite respectable, because the number of people that are still on these platforms, any one of them have 20, 30 years of experience doing these things. So when they achieve something, that's usually not something that a new person can quickly learn and like suddenly revolutionize.
Is that implying that it's basically just a bunch of grandmasters playing chess together? Do you have any 25-year-olds or 20 or 15-year-olds that are playing with these devices?
For the older devices, I would say it's mostly grandmasters playing chess with each other, like the same 20 people beating each other up. Although there is cases where someone who is another like 40-year-old person who has been in the software industry but was interested with Commodore in the 80s, but never did any like competitive demo programming in the 80s, 90s. But now, after 20 years, yeah, they settled their life. Now they have that extra bandwidth to kind of get a Commodore, start getting into it, and then like a year or two later, they may be into the heat of the competition, and they may achieve really great things because now they have also a lot of life experience and stuff like that. So there is an age thing, not necessarily how many years have you been in the demo scene thing. There are people who come in and like break the world in 2 years, but they are usually not 15 years old.
Hey friends, I want to take a moment to thank our new sponsor, BetterHelp. One of the things that came out of COVID wasn't just the ability to do remote work, but it was also better remote therapy. And BetterHelp is the world's largest therapy service. They've had over 5 million video sessions, calls, chats, and messages every month. They're on a mission to make sure that everyone has easy and affordable and private access to high-quality therapy. It's a really great thing that we talk about here on the podcast is mental health, how important it is, especially as so many of us engineers have a feeling of imposter syndrome, and we get overwhelmed. It can be tough to have your brain stay in that problem-solving mode when you're facing with a particular challenge in life. And often a therapist can help you become a better problem solver and make it easier to accomplish your goals, no matter how big or how small. Being able to connect to a therapist with a tool like BetterHelp is a great option. When you want to be a better problem solver, therapy can help get you there. Visit betterhelp.com/HanselMinutes today to get 10% off your first month. That's betterhelp.com/HanselMinutes. One of the things that's worth pointing out is that in the space that I work on the web, we hear a lot of people like to use the word full stack developer. And I always think that that's kind of funny because for that's for some value of the size of a stack. Someone might say, I'm working on the metal, and they really just pressed F12 in Chrome, and they're feeling very low level. The thing that's interesting about the 6502, 6510 is that when we say you can understand the metal, you go all the way down to like an oscilloscope. Like I know the Commodore 64 people bringing an oscilloscope out to debug where the cycle is and where we're on the edge here in order to. So there's an expression here. The reason I'm asking this is that there's an expression at the hardware level. Maybe you could say something about this VIC, the video interface chip, thinks about an electron beam on a scan line, even if we're displaying it today on a CRT, on an LCD or in an emulator. It knew about an electron beam sweeping back and forth along a cathode ray tube. You're still having to think about that, right?
Yeah, very much so. I mean, there's an entire, maybe half of all Commodore effects are things that have to do with strict timing around that beam. So it's a crucial factor in demo coding. I believe it's that statement applies to a lot of other platforms too. I'm not 100% sure, but I remember someone mentioning the Xbox 360 the main, you hit the center button and the main menu pops up. Remember the first main menu, like when it used to be this little box in the middle of the screen?
I have a 360 right here. I can see it. Yep.
Yeah. So that's a raster interrupt. That is an interrupt that was being listened to through the beam scanner raster stuff. And when you press that middle button, wherever you are in the game, whatever app you're in, that thing pauses and the thing comes up. So it's a relevant thing. It's very much used even in today's systems. But you're right. There's a concept of hardware familiarity, which again very much applies to today. Like, if it may not apply as much on the web domain, but there are domains where we work very closely with memory and how data is laid out in memory and how a CPU accesses memory, in what sequence, in what patterns. The entire data-oriented, development idea is based on memory layout and memory access, and that's what we do in games, for instance, to achieve really high performance frame rates and like being able to achieve crowded environments, etc. We do a lot of these tricks with the knowledge of exactly how the CPU works and how memory works. One of my favorite lines about this concept comes from Mike Acton, who was the engine director in Naughty Dog, and then went over to Unity to work on Unity Engine's data-oriented tech stack called DOTS. So Mike has this famous C++ con speech from C++ CPPCon 2014, I believe, where he talks. He was kind of one of the first. These concepts were better known in the game industry for a longer time, but this was like the first time he kind of made it more popular in the wider software industry. And there he mentions about like object-oriented programming and some of the pitfalls that we fall into while using paradigms like that. And he says, like, people think software is these, objects flying in the ether. We think of software that way. We design it that way. That's how we talk about it. We put associations between these objects that fly, that come into being in the ether, fly over here, and then tie with this other object and stuff like that. Where in reality, it's a thing that runs on a physical CPU that is accessing a physical RAM in sequential manner or random, all over the place if you didn't do it right. And there is no ether. There are no objects. This thing really runs on a real hardware, and we need to understand what that hardware likes to see. What does it like to do in accessing memory, in accessing cache? How do you optimize cache access, etc.? So these are very real topics. Even if you have a cloud service in Azure or AWS or something, and you're paying for that CPU time that's running in the cloud, there's a lot of gains that you can get by optimizing things, and it takes hardware knowledge. So
I had a gentleman on the podcast several years ago who was a PhD at IBM before SSDs, but when the cloud still existed, and he changed the file system driver so that the disks would spin differently and the access of the files would be improved so that they might save energy and spin less, because it was, nice. I could change the file system, which changed how the disk is accessed. And you do that N hundreds of thousands of times, and it's going to save, $1.6 million per unit of whatever, entirely because of some software that saw inefficiencies of the file system driver. And I remember on floppy disks, you can tell when you're spinning on the center part of the disk versus when you're on the outside, and you're getting different access speeds.
Yes, very much so. Again, sometimes I feel like I sound also like a boomer when I say things like this. But we have to accept the fact that, the 6502 or 6510 or hardware-aware programming, etc. Yes, these are not necessary for everyone, every project. But there are projects in the very, modern world today. We deal with problems that are related to these topics today. Not every software engineer does. That is true. But there are fields that optimization is important, that energy efficiency is important. there are the techniques that gentleman in IBM uses to save on a data center. I am sure some of that may apply to mobile devices, like, because in mobile, then we are talking about battery time. So anything and any type of energy performance throughput related question mark that we run into in this industry usually ends up being solvable or improvable upon by some hardware and CPU and memory knowledge.
That is so important, that relationship between the physical and the virtual. People of a certain age have that intuitively, but when that stopped mattering, when disk fragmentation stopped mattering, when I could just throw a file, have unlimited memory, and just make an object, make 10,000 of them, and I never thought about it. So this brings up a really interesting point, that the demo scene is a talent pool then for game developers. There's an overlap in skills here, that this must be very valuable to you as a studio owner.
Correct. I mean, there's a huge overlap. There has always been a huge overlap between the skills involved in Demoscene and game development, especially before the time of the engines like the Unreals and Unities becoming available to the wider public. To make a game, you had to write your 3D renderer or 2D renderer, and who knows how to write a 3D renderer? Like there aren't a lot of problem domains that people can go into and learn these things. And Demoscene was a natural breeding ground for people who knew computer graphics, even from the 90s. And some of the biggest studios today have roots in Demoscene. DICE, the DICE in Sweden was originally formed by a demo group. Remedy in Finland was originally formed by, I think, combination of 2 or 3 demo groups coming together. So there has always been game studios that were formed by entrepreneurs that come from a Demoscene background. But more commonly, there's always a pool of talent that would become employees in game studios that had Demoscene background. And this continues to be the case today, especially over in Europe. This may not apply as much to the United States game industry, because for whatever reason, Demoscene never really became a huge thing in the States. But in Europe, it's a big thing, and it's that's overlap and tie is very strong. I think it helps even the entrepreneurs. Like I am in that position right now. I have my game studio with 2 other co-founders who are also my Demoscene group members. So we are forming a company like that. We hope to be one day like DICE or Remedy, another team that was a Demoscene group that became a company. I think one of the things that I notice in the way we work is that multidiscipline aspect of Demoscene is another super critical thing. So when you're making demos, you're especially back in the 90s, if you're a bunch of teenagers making demos, you were 14, 15, 16-year-olds, 6 kids coming together. 2 of you are programmers, 2 of you are graphics artists, 1 of you is a musician, 1 of you is a spreader that does like the mail trading of the discs and stuff like that. So you have these 4 or 5 people that are specialized in completely different disciplines, and none of you is the manager of the other, so you kind of have to make this whole thing work in a multidisciplinary fashion. You as a coder have to be able to talk to a non-technical person, an artist, and be able to communicate. And they need to be able to explain an artistic decision to this non-artistic, non-visual person, a coder. That discipline doesn't happen a lot in a lot of other software industry verticals. In many cases in software industry, when we're working with a team of software engineers. Like the furthest discipline may be a PM, right? Like that's like 2 teams over there. But games are very much multidisciplinary, and getting a bunch of artists and coders and musicians and voice talent and producers and all that kind of work together harmoniously is a difficult problem. And demosceners kind of go through that on earlier ages and without any monetary motivation behind it. So they have a different way of internalizing it at an early point in their career. And then that translates really well into this working environment in the game industry.
Yeah, I think it reminds me of my kids right now are 16, 15, and 17, and they're doing group projects at school, except they don't care about them. So then they have problems
Right.
with interpersonal dynamics. But if you deeply care about a project and that love of the excitement of the scene is what brought you together, you're learning group dynamics, you're learning teamwork, you're learning PM, you're learning dev, you're making it happen. And that joy, it sounds like, has propelled you for 40 years or more.
Yeah. I mean, it's certainly also worth noting is the concept of shipping, right? That's something we know in the professional industry, how important shipping a project is. Again, in Demoscene, we got to kind of experience that push, that importance of shipping. What you lose when you don't ship, when you bring a project to 90% complete and not ship, that is very clear when you're a demoscener and you're trying to finish this demo for this particular deadline, a demo competition at a party in Berlin or whatever. And you miss that date, you're done. Like that's horrendous. If you miss that date and you don't ship, you just lose so much impact, so much return on investment, that you kind of have to learn how to finish that final 15% of a project, right? Which is the hardest, which is, I claim that this applies to not just Demoscene, to any professional project. The last 15% of a technology-based project, any software project, any game project, is uniquely difficult. And there are things that you learn by completing that final 15% that you can't learn any other way, right? I can't tell you verbally. I can't write a book about it and you read it. There's no way that anybody can teach you how important that final 15% is and how to survive that final 15% of a project. You can't learn this from a video. You can't learn this from a course. There's only one way on the planet to learn this, and that is to actually bring a project to that 85% mark and then pushing through to that final ship. Again, Demoscene is an area where you get to experience this skill, where you get to practice this skill and get better at it. Because the time it's different than, hey, me and my two friends decided to make this little mobile game and we will ship it, like we'll put it to the Play Store. I don't know when, that's a different thing. That's a whole different game. Actually shipping something to a crowd and getting feedback on it and competing with it and getting criticized for it, all of those things are very real. And Demoscene just happens to be a great place to do this, to experience this.
Very cool. Well, thank you so much for hanging out and sharing your wisdom and your knowledge about the Demoscene to us today.
Absolutely. My pleasure.
We have been chatting with Bilgem Çakır, the CTO of Clay Token. You can check out Commodore 64 Demoscenes by just using your favorite search engine. And we've got videos online of lots of great demos, both classic and recent. And then for the references of the folks that I mentioned on the show, the gentleman who did that hard drive thing for IBM was Dr. Anthony Heileck. That was episode 374. And then last week, we had Gustavo Pezzi, episode 858, and he was talking about writing your own 3D renderer in C. So we're going to be doing a series and learning more about this great stuff. And I really appreciate you hanging out with me, Bilgem Çakır, CTO of Clay Token. Will we be able to hear about your stealth game anytime soon? Where do we learn about this and follow you?
Right now, the best place to follow us would be LinkedIn. We have a LinkedIn page. I can't say when, but if you follow Clay Token on LinkedIn, hopefully in not too distant future, there'll be some interesting stuff that we announce.
Fantastic. This has been another episode of Hansel Minutes, and we'll see you again next week.